This is the walkthrough video for PCTC 2021-2022 round 2 question 10 noughts and crosses. Okay, so this question is not necessarily algorithmically difficult, but it's extremely difficult from an implementation point of view. There are so many things you have to do, and the code you write is going to end up being relatively long, and it's just so many decisions to make, and trying to implement it accurately is difficult. But essentially, we're given a noughts and crosses board, but it's 4x4 and not 3x3, and we need to figure out how many rows, columns, and diagonals of 3 exist in our board. And really, the fact that this is a 4x4 is what makes this so difficult, whereas if it was a 3x3, it'd be relatively easy. Yeah, again, there are going to be loads of different ways you could solve this problem. I'm going to show you the way that I did it, and I used a couple of tricks to try and make this a bit faster. But yeah, the very first thing to do, as always, is to input the data. And what I want to do is I want to create a 2D list that essentially just represents our board. So let's create our board, and that's going to be an empty string 4 times, and that entire row 4 times. So this code, it basically just creates a 4x4 2D list in Python, where every element is just an empty string like this. So we got our board. Now let's take in our inputs. There are 16. Oops. So there are 16 inputs. Let's do that, and let's take let's just call it imp, and we want to do input, and the inputs we're given are actually in letter and then number format, which is just useless. Like it's not useful to us. In Python, we want number. We don't want letter number, because Python uses numbers and not letters. So we need to convert A, B, C, and D into numbers. And I think doing it at this stage in our code is probably the easiest. So I'm going to take our input and do a dot replace A with a 0, because it represents column 0. Then I'm going to do the same thing with B. I'm going to replace B with 1, because it represents column 1. I'm going to replace C with 2, and finally I'm going to replace D with 3. So now our input is actually in a useful format. We can begin to process it. So what symbol we place at that point, whether it be an X or a 0 or an O, it depends on whose turn it is. And we're told that noughts, player 1, which is noughts, goes first, and then player 2, which is crosses, goes next, and it alternates like that. And so the 0th input we're given is going to be noughts, then the second input we're given is going to be noughts, and 4th, and so on. Whereas the 1st and 3rd and 5th and so on inputs we're given are going to be X's. And so to figure out whose turn it is, we can just have an if statement that says if I mod 2 is equal to 0. So if this is an even input, so if this is the 0th input or the 2nd input or the 4th input or so on, then that's going to be player 1, whereas otherwise it's going to be player 2. So symbol we're going to set to equal O, and if it's an odd input, then symbol's going to be X, because it's representing player 2. And finally, we now need to add this symbol to the position at the imp specified. So we want to take board, and the first index that we're going to input is the row. And what's the row? That's going to be represented by the second number in our input. So that's going to be index 1 of our input, because it's going to be this number. But actually, these rows are reversed. Now, I believe that you don't actually have to bother doing it in this order, and that if you kind of input these rows in the opposite order to what the question says, you can still get it right. But for simplicity, for intuition, if you were to try and play around with this code and actually write it and print it out yourself, it's just easier to try and copy what the question does. And so we want to add these rows to our board list in the order that shows us here. And so for some reason, this question decides to count from the bottom up, whereas Python counts from the top to the bottom. And so to get the actual row that we want to add this to in Python, all we need to do is actually just do 4 minus that. And because this is still in a string, let's convert that to an integer. And so 4 minus that integer will give us the actual row that we're interested in, right? If you imagine in this row, for example, that's 3 according to their numbering. 4 minus 3 is 1. And according to our numbering, according to Python's numbering, that's correct because this is row 1. And you can kind of verify that for the other 3 rows if you want as well. But that's the math that gives us the correct row. Now for the column, fortunately, because we already processed our input up here on line 4, the column is essentially just given to us. So we can just reference the first number in imp. And so this is the position in our board where we want to add our symbol to. And so let's just say that is going to be equal to symbol. And so really, after a whole 11 lines of code, we've only just finished processing our entire input to create this noughts and crosses board, which is part of what makes this question so difficult. But yeah, you can print this out if you want to really verify that the board is correct. And again, if you're a bit confused by some of the things I've done here, then pause the video, copy this code down, have a play around, print stuff off, change stuff, and just make sure you understand what's going on. But yeah, this is our board. Now we can get to the actual logic. We can get to the meat of the problem where we need to calculate the points of each of the players. And this is a part where there are just an infinite amount of things you could possibly do to do this correctly. But what I'm going to do is I'm going to first check the rows. So I'm going to check to see if that's a 3 in a row, if that's a 3 in a row, or actually, if that entire thing is a 4 in a row. Because if that entire thing is a 4 in a row, I need to add 2 to our score. So if you go back to the question, it tells us that if 4 in a line were achieved, this will score 2 points. And so if all 4 of these are the same thing, that gives us 2 points. And if they're not the same thing, then maybe if those 3 are the same thing and those 3 are the same thing, we just get 1 for each of those. And we can apply that logic to all 4 of our rows. And instead of trying to figure out the logic to apply that to our columns as well, like that, what we can do is we can just transpose this board. And transposing really just means we're switching out the x and y coordinates in our list. And so if we switch out the x and y coordinates, we can run the exact same code on the rows because the columns are now the rows. And so this will now actually be a row, and we can just run the exact same code to check for 3 and 4 in a rows. So hopefully that will make more sense once we code that up. So let's code that up and we'll deal with diagonals a bit later. So what we want to do, we want to go for line in range 4, because there are 4 lines. We want to check to see if board is equal, no, we want to check to see if line.count symbol, and let's set symbol up here to be equal to O. And we're going to say if there are 4 of these symbols in that one line, then our score is going to increase by 2. So we also need a score variable, and then we're going to set that to 0 to begin with. And what we're doing is we're saying every time we see a line, if the line has all 4 of our symbols, then the score increases by 2. If it doesn't, then if it has 3 of our symbols in a row, we still want to increase the score, but this time by 1 point and not by 2. So the way I'm going to do this is I'm going to say if symbol multiplied by 3 is in the joining of that line, then let's increase score by 1. And so symbol multiplied by 3, in this case, for example, would just be that. We're just taking this one string and multiplying itself by 3 to get that. And what this part of our if statement does is it kind of just joins our line, because our line is represented by a list like that, for example. And so what our join command does is it converts all of that into a really simple string, which is much easier to process. Okay. And just like this, we've processed all of our rows for a given symbol and added the scores accordingly. And as we discussed just beforehand, we now want to transpose the list so that we can just rerun the exact same code. So to transpose the list, let's do, and actually I made a slight mistake up there. Let's do for line in board. We don't care about the range, we only care about the actual line. And so now we want to do board is equal to itself, but transposed. And to transpose something in Python, you can just do that. And then we want to run the exact same code twice, like again. And so we can just run this entire thing twice. Awesome. So now we've written the code that finds all of the rows that are 3 or 4 in a row, and all of the columns that are also 3 and 4 in a row. And we also reset the board back to its initial state. So this is a bit confusing. Hopefully it makes sense. Hopefully you follow, but it's fine if you don't. Just pause the video and have a bit of a think. Okay, so now we want to deal with diagonals, and this is slightly harder. There's no neat solution, at least from what I saw. I don't think there's a neat solution. But what I'm going to do is I'm going to first look at that diagonal, and I'm going to see if all 4 of them are the symbol of interest. And if they are, I'm going to add 2 to our score. If it's not, then I'm just going to check, just like we did for the rows and the columns. I'm just going to check to see if 3 of them are a symbol of interest, and if they are, I'm just going to add 1. So that's that column. That's that diagonal done. Now this diagonal, I'm just going to extract those 3 cells and check if all 3 of those symbols are the same. I'm going to do the same thing for that diagonal. And so we've now covered every potential diagonal that goes from top left to bottom right. But of course, there are still more diagonals, right? There's still that diagonal, and that diagonal that we need to check. But similar to the row column thing I just discussed, I can't really be asked to write that code, like the code for the green bits, and then slightly modify it for the code for the pink bits. And so what I'm going to do is I'm going to write the code for the green bits. Then I'm just going to flip our noughts and crosses board horizontally. So like that's going to go there, that's going to go there, that's going to go there, and that's going to go there. So I'm just going to flip our board horizontally. And what that means is that this diagonal, for example, is now going to be along that line. This diagonal is now going to be along that line, I believe. And this diagonal is now going to be along this line, which match the green ones. And so we can just run the exact same code just by flipping the board. Okay, so let's write that diagonal code. So what we want to do, we want to first extract this main diagonal. And the way I'm going to do that is I'm going to say, I want to take board I for I in range 4. And what this does is it takes I from 0 to 3, and I'm just going to extract the cell at that position. So it's going to extract the cell at 0, 0, the cell at 1, 1, the cell at 2, 2, and the cell at 3, 3, which is this diagonal. I'm going to put that all into a brand new list. Okay, and now what I'm going to say is I'm going to run very similar checks to what I did up here. In fact, the checks are so similar, I am just going to copy paste that. Instead of line, let's change that to diag, and same for down here. Awesome, that is our main diagonal checked. Now we need to check our 2 side diagonals, this one and this one. So the code to extract the cells is very similar to this one, except that we want to change the range from 4 to 3, and we want to change the I to I and I plus 1. And so in this specific case, the I plus 1 represents the x coordinate. And so the things we're extracting are going to be, so if I goes from 0 to 2, because in this case we're only going up until 3, so I goes from 0 to 2, and we're going to extract 0, 1, 1, 2, and 2, 3. Those are the 3 coordinates that we're extracting in our for loop that I've just written. And that's going to be 0, 1, that's going to be that, 1, 2, that's going to be that, and 2, 3, that's going to be that. And so I'm extracting that diagonal in this case. And that's what's represented by this new variable called diag. And I'm just going to check to see if all 3 of them are the same. So if diag.count symbol is equal to 3, then score is equal to itself plus 1. And notice in this case, because this diagonal only contains 3 symbols, we don't have to bother checking for 4 symbols, because we know it contains 3, right? This diagonal just only contains 3 symbols. And so we can just go straight to checking for that. And now I want to do the same thing, but for the other small diagonal, which was that one. And so as you might have guessed, the code is very similar, so I've just copy pasted it down here. But instead of adding 1 to this x coordinate, we're going to add 1 to the y coordinate. And that essentially the same logic I described earlier applies. It's just now we're going to be checking this new diagonal. And awesome, that's all of our diagonal checks done. But again, as we discussed earlier, that only checks all the diagonals in one direction. That only checks all the diagonals that are going in that direction. And so to check all of the ones that are also going in that direction, let's just flip the thing horizontally along that line, and then we can just copy paste the same checks. And how do we flip a 2D list in Python? Well, we can just go through every line in our board, and we can reverse the line like that. And so just like this, in this one line of code, we flipped our entire board vertically. And just like before, we want to run all of this code twice. So let's add another for loop. So for thingy in range 2, we're just going to run all of this code twice. And the fact that this code is also run twice means our board is once again reset. So even though we flip it back again, which resets it back to the original position. So yeah, this is pretty confusing, quite a lot of code, but we've done all the checks we need. We're very close to solving this problem, because we've done all the rows and therefore column checks. We've done all the this direction diagonals and therefore also the other direction diagonals. We've only done that for one symbol. We need to do that for both symbols. And so let's do for symbol in this string, we want to run all of this code that we've just written. And so let's once again select that all and indent all of that and get rid of that line. So we're going to run all of these checks for both the naught and the cross. And the score in this case is something that we need to save. And so let's do scores, or let's do answer. It's going to just be a blank string. And after I've done all of the checks for the naught, so right at the end of this for loop, I'm going to our answer, I'm going to add the score. But because score is an integer, let's just convert that to a string. So I'm going to add the score to our answer. And then I probably also want to add the dash, because the format that I want us to print it off is score1 dash score2. And so let's just do that. And so yeah, that's our code done. Now we just need to print the answer. But you may have noticed the issue, which is that we're adding a score to our answer, then dash, and we're doing that twice. So we're adding another score and another dash. We don't want that extra dash. So let's just print answer up until the final element, which is just that final dash. We don't want that final dash. And finally, once we submit this code, we should hopefully get all 10 points. No point, no, okay. Great, this is some live debugging. This is such a long and complicated program, so I guess it's not unreasonable to come across an error. So it tells us that replace must be a string, not an integer. Yes, so I think I took a shortcut earlier, and that clearly didn't work very well. Because yeah, you obviously can't replace a string with an integer. So let's fix that. And therefore we also need to turn that into an int, because that's now a string. Now let's see if this works. Awesome. Now let's submit that and hope we pass all the test cases. Yep. Yeah, so this was just a very difficult problem. This code is very confusing. Like, there's no way around it. Whatever code you write to solve this problem is going to be very confusing. Lots of things to manage. But if you break it down like we did, we broke it down into processing our input, then looking at the rows, then looking at the columns, then looking at the diagonals from left to right, and then looking from the diagonals from right to left. Yeah, and once we did that, it became a bit more manageable. But yeah, again, go to the GitHub link in the description, play around with this code, write this code, print stuff off, make sure you understand it, because it's not easy. So like yeah, don't be worried if you're confused, because you probably are confused, because it's difficult, and I've just written 50 lines of code in like 10 minutes. But anyway, yeah, hope you enjoyed that and learned something.